everyone. Welcome to an exciting journey into the mysterious world of quantum physics and nuclear physis. This is where the normal rules of physics break down, and things start behaving in the strangest ways. Let's dive in. What is quantum physics? Quantum physics is the branch of physics that describes very small particles, like molecules, atoms, electrons, protons, and neutrons, also known as subatomic particles. Why is quantum physics so different? Classical physics can describe many aspects of nature at an ordinary scale, but is not sufficient for describing them at very small submicroscopic scales. Key concept in quantum physics: wave-particle duality, an experiment which demonstrates that a quantum object is at the same time a wave and particle. Particle. Particles are sent on two slides. The particles touch the screen randomly. Wave. A wave is sent on two slits which make it interfere. This results in fringes on the screen. Quantum. A quantum object is sent on two slits. The wave suddenly reduces into a particle when touching the screen, and more likely at the positions where the wave was more intense. At the end, one observes impacts as for particles, and interference fringes as for waves. Add an observer. If an observer measures through which slit the wave goes, then the wave reduces and goes only through one of the two slits now. No interference can occur anymore. So n fringes appear on the screen. The observer has modified the experiment. Heisenberg's uncertainty principle. We will take an example to understand uncertainty principle. Let there be a blindfolded person in a room searching for a ball whose velocity he has been told, but not the position. He will come to know the position of the ball when the ball collides with him, but at this point of time, the velocity of the ball would have changed due to the collision. This is precisely what Heisenberg stated, that exact velocity and exact position cannot be determined simultaneously. Quantum superposition is a phenomenon where a very small particle can be in multiple states at the same time. For example, if we flip a coin and it's spinning in the air, it could be heads or it could be tails. Quantum superposition says that it's in both of those states at the same time, until it falls and is determined to be heads or tails. For example, if you think about an electron, it has two states, spin up and spin down. In quantum superposition, the electron exists in both spin up and spin down states simultaneously until it is measured. Quantum entanglement. Now let's explain quantum entanglement, which is a phenomenon where two or more particles are so strongly coupled to each other that if you know the state of one particle, you can immediately know the state of the other particle. For example, imagine two entangled coins. If you look at one coin, you immediately know the state of the other coin, which is far away If the first coin is heads, the second coin is automatically heads, no matter how far apart they are. Once the state of one is determined, the state of the other is immediately determined. For example, imagine two electrons are entangled. If you measure the spin of the first electron and find that it is spin up, the spin of the second electron is immediately determined to be spin down. This entanglement state does not change no matter how far apart they are. Conclusion: quantum physics takes us into a bizarre yet beautiful world where particles behave like waves. Observation changes reality, and entanglement defies the laws of space and time. Even though it seems strange and counterintuitive, quantum physics is the foundation of many modern technologies, like quantum computing, lasers, and even GPS systems. Thanks for watching, and I'll see you in the next video.